Assalamualaikum. My name is Varisha Kaval and my registration number is 16T86. Today is our lecture 17, which is about FIR filters, which is the finite impulse response. Actually, these are the filters which depends upon only on the input. But as compared to infinite impulse response filters, they depends upon both input and output. So the formula for FIR is y of n is equal to I is equal to 0 to k bi of x of n minus I, where bi is here the filter coefficient. Actually, the desired objective is to pass and reject some band. So the formula can be written as b0 of x of n plus b1 of x of n minus 1 plus b2 of x of n minus 2 up to so on bk of x of n minus k. Apply z transform here. It gives y of z is equal to b naught x of z plus b1 x of z raised to power minus 1 plus b2 of x of z into z raised to power minus 2 up to so on bk of x of z raised to power minus k. If we need to find the transfer function, it is found by using this formula: b0 plus b1 z raised to power minus 1 b2 z raised to power minus 2 up to so on bk z raised to power minus k. Now I explain it through the example. For example, y of n is equal to 0.1 x of n plus 0.25 x of n minus 1 plus 0.2 x of n minus 2. So first step is to apply the z transform, which gives x of z plus 0.25 x of z is power minus 1 plus 0.2 x of z into z is power minus 2. Transfer function is find by using dividing the y of z over x of z, and here actually we take common as x of z. It gives 0.1 plus 0.25 z raised to power minus 1 plus 0.2 z raised to power minus 2. So it is the transfer function. Next topic is Fourier transform design. We have a derivation to find the h of n for n is not equal to 0 and for n is equal to 0. So here h of n is equal to 1 over 2 pi minus sigma c to sigma c h of e raised to power j omega into e raised to power j omega d omega. From this formula we find the formula for h of n for n is equal to 0 and for n is not equal to 0. For n equal to 0, h of n is equal to 1 over 2 pi minus pi to pi. As we know that in digital domain the maximum frequency is pi, so h of e raised to power j omega into e raised to power j omega multiply 0 d omega, it gives 1. So for h of 0 it gives sigma c over pi. Then for h is not equal to 0, the same method is used and it gives the formula sine sigma c n over pi n. These are the formulas for the low pass filter. for high pass filter, the only change is h of n is equal to pi minus sigma c over pi. High pass. It is same for the also the high pass filter. Then for band pass, as we know that the band pass is a combination of both high and low pass, so the formula for this is sigma high minus sigma low over pi. And for n is not equal to 0, it is sine sigma h n over pi n minus sigma minus sine sigma l n over pi n. And for band reject, the formula is only changed by having a plus sign in between, and for n is equal to 0, the same formula, only difference is h of n is equal to pi minus sigma of h plus sigma of l over pi. So now we take the example. For example, if we need to design a 3-tap filter, 3-tap low pass filter. The method for this is, first we use the formula 2m plus 1 is equal to a number of taps. So here the number of taps is equal to 3 and it gives m is equal to 1. As we are designing a low pass filter, so formula for this is h of n is equal to sigma c over pi, and here the value of sigma c is equal to 8000 Hertz and fs is 800 Hertz. So this is the formula for n is equal to 0, and for n is not equal to 0, formula is sine sigma c n over pi n. After finding the values for h of n and w of n, then in last the formula used here is h of n multiply w of n. It gives the value for the windowed method. So this is all about today's lecture. Thank you.